Welcome to our tutorial on mastering rate limiters in system design interviews. A rate limiter is like traffic control for your servers. It ensures that only so many requests can come in at a time. Imagine you're running an online store, and suddenly, too many people start buying the last item. That's where rate limiting comes in to prevent overwhelming your server with too many requests. In tech interviews, understanding how to implement and design rate limiters is crucial. For example, consider using a token bucket algorithm or leaky bucket model. These methods allow tokens, requests, to be added at a constant rate while being consumed for each incoming request. This ensures smooth traffic flow without overloading your system. Welcome to our journey into the world of rate limiters. Today, we'll dive deep into what they are and why they're essential in system design. First up, we'll introduce you to the concept of rate limiters and explore some key patterns that make them effective. Then, we'll get hands-on with a real implementation using the token bucket algorithm. We'll also look at how these concepts play out in practical scenarios, highlighting good practices versus common pitfalls. Lastly, we'll test your knowledge with a quiz on common mistakes to avoid. By the end of this tutorial, you'll be well-equipped to tackle rate limiters in your system design challenges. Hello everyone. Welcome to our introduction to rate limiters. Imagine you're building an app that fetches weather updates, and suddenly thousands of users start hitting your server at the same time. That's where rate limiters come in. They help by limiting the number of requests a user can make within a certain time frame. Say, 10 requests per minute. This is not just to keep your servers healthy but also to ensure everyone gets fair access. For example, if you're developing an API for checking stock prices, rate limiters prevent one user from making hundreds or thousands of requests in rapid succession, potentially overloading the system. They're widely used in web services and distributed systems to manage traffic efficiently and protect against abuse. So, whether you're preparing for a system design interview or just curious about how these work behind the scenes, understanding rate limiters is key. Let's dive deeper into this concept together. Welcome to our tutorial on the token bucket algorithm, a key concept in system design interviews. This algorithm helps manage requests by maintaining a bucket of tokens that can be consumed. Tokens are added at a steady rate over time. Let's dive into the Python code for this implementation. We have a class with an initial capacity and refill rate. The method checks if there are enough tokens to fulfill the request, refills the token bucket based on elapsed time, and updates the number of tokens accordingly. For example, if you need 5 tokens and currently have 3, this function will return true and deduct those 3 tokens from your bucket. If not enough tokens, it returns false. This mechanism ensures a smooth rate limiting process without overwhelming the system. On this slide, we're looking at the output of running our code. Essentially, this snippet of code is using a token bucket algorithm to manage requests. Let's break it down. We have A with a capacity of 10 tokens and a refill rate of 2 tokens per second. The key action here is calling. This simulates consuming 5 tokens from our bucket. If there are enough tokens, the method returns true. Otherwise, it returns false. In this case, if we run the code with these parameters, since we start with a capacity of 10 and consume 5 tokens, the output will be, there's no issue because we have sufficient tokens to satisfy our request. This concept is crucial in system design interviews for understanding rate limiting mechanisms. Welcome to our tutorial on real-world usage of API rate limiting. Imagine you're developing an app that handles user requests, and you need to ensure fair use while preventing abuse. Here's how it works. We use a token bucket algorithm to manage this. In our code snippet, checks if a user has enough tokens for their request count. If they do, the request is allowed. Otherwise, it's denied. For instance, let's say each user can make 10 requests per minute. This function ensures that users don't exceed that limit. It's like giving everyone a cup of tokens each minute, and if you run out, you have to wait for your next turn. This system is crucial in interviews discussing rate limiting strategies, ensuring our APIs remain stable and secure. Welcome back. Today we're diving into the world of rate limiters, specifically looking at good and bad approaches. Let's start with our good approach. Using a token bucket algorithm is like having a buffer that refills over time. This way, requests can be processed smoothly without getting blocked. Contrast this with the bad approach using a simple counter. Imagine you're on a busy website. If everyone hits it at once, your counter gets exhausted quickly, and everything locks up. Now, for our good approach, we cache tokens and refill them periodically. Think of it like having a queue of tickets ready to go, ensuring steady service. The bad approach, checking every single request one by one. That's like stopping traffic every time someone wants to enter a building. Not only is it inefficient, but also leads to high latency for everyone. Alright, let's dive into today's quiz question. What happens if you forget to use await in your coroutine? Well, first off, the coroutine is never actually executed without that await. Python simply returns a coroutine object instead of giving you the result you expected. And guess what? You'll get a runtime warning saying, coroutine was never awaited. This can be a common beginner mistake. Imagine you're building a rate limiter in your system design interview, and you forget to use await. You might spend ages debugging why it's not working as expected, so always make sure to wrap your coroutines with await. That's the key to getting those results right. Welcome back. In today's key takeaways, we dive into the essentials of designing an effective rate limiter. First up, the token bucket algorithm is a powerful choice because it allows flexible control over how requests are throttled. Imagine you have a bucket that can hold tokens. Each token represents a request allowed within your limits. If the bucket fills up, incoming requests get delayed until more tokens are available. This method ensures smooth traffic flow while managing bursts effectively. Next, implementing caching is crucial for optimizing performance. By storing frequently accessed data in cache, you reduce the load on your servers and improve response times. For example, if a user's request can be answered from the cache instead of hitting the database, it's like serving them a quick snack rather than waiting for dinner. Lastly, we must ensure fair usage to prevent resource abuse. This means implementing mechanisms that fairly distribute tokens or quota among users. Think of it as giving everyone an equal chance at getting a token in our bucket example. By following these principles, you can build a robust rate limiter system.